Hey, very good morning to one and all. I am Praveen and I'm currently pursuing BTech third year at Aditya University. So today we are going to build and demo a real world project where an AI works completely offline without internet. Looks interesting? Let's get into it. Coming to the project details, what we need to build an offline customer support chatbot with Ollama and Llama 3.2. Okay, these are some new terms, Ollama and Llama 3.2. I'll explain it to. So, coming to the objective, what we need to build? We need to build a functional offline customer support chatbot for a fictional e-commerce store using Ollama and Llama 3.2 language model. So there is nothing real e-commerce store. We will create one e-commerce store, name it as something chic boutique store. I'll show it to you later using Ollama and Llama 3.2 language model. By building this task, I learned how to interact with large LLMs on my mission. I mean, on my personal laptop. Master fundamental prompt engineering like zero shot versus one shot. Yeah, okay. Coming to the project background and industry context. So, in the modern industry e-commerce store, we will see everywhere chatbots where it can address the queries of users and solving the issues like that. Every e-commerce store has been using a chatbot. For example, whenever you visit Flipkart, there is an chatbot, and WhatsApp also you're getting a chatbot called Meta AI, and in the Amazon also we are getting an e-commerce. It is also an e-commerce store where it can also consist of an chatbot where the platform handles millions of daily interactions concerning order tracking, return policies, product inquiries, and account issues. While cloud-based LLMs are also there, for example, OpenAI, Gemini, Google offer the state-of-art capabilities for automating these interactions. They come with a significant challenge, mainly data privacy. Sending customer data, which can include names, address, and order histories to the third-party servers. So what happening? Data is not protected. So third-party servers create substantial legal and security risk under regulations like Europe's GDPR and California CCPA and India's DP Act 2023. So for that purpose, we need to make a chatbot which works completely offline on your local machine. So this is where local on-premise LLM deployment becomes a strategic advantage. So we don't need to interact with the third-party AI APIs. You can simply run on your local machines by running an LLM entirely on local hardware. A company can build powerful AI-driven tools without any sensitive data ever changing its own network. So in this project, we are going to use Ollama and Llama 3.2. So core concepts we need to be understand before building this project. What is an LLM? An LLM is a type of neural network which is trained a vast amount of text data, not the image data or video data, large amount of text data, so that the neural network, which is a model, will learn more about the text. Its core function is nothing but it predicts the next word based on the previous word. So next word means here words will be converted into token. Token will be converted into embeddings, which will be stored in the vector store in a sequence. For this complete detailing, I have created another video in the multimodal RAG analysis. I have I have told you how the words will be converted into vectors and how vectors will be stored in the vector store. You can check out it that. So this allows generate human-like text, answer questions, summarize documents, and more. Okay, LLMs are probabilistic models, not knowledge bases. They generate the output based on the previous word and probability. The generate based on patterns learned during training. Okay, which means they can sometimes produce plausible but incorrect information, a phenomenon known as hallucination. So while dealing with the LLMs or AI models, you can definitely got this hallucination concept. In my recent project, this project also, the LLM has been hallucinated. For example, when I send a query, it hallucinated and created a company email. Without the email is not in existence, but itself created an email as a supporting team. So it's not a correct thing. The model should uh, not hallucinate and should give general data and reliable data, not the creating another data. And another thing is while developing this application, once I send a query, what it will does, it will created its own UI and saying that go to that button, this placing order, go to dashboard page like that. So LLM should not hallucinate. For that purpose, we have another techniques like RAG, retrieval augmentation. So coming to the Ollama. Here we have used Ollama. Ollama is an open source tool that simplifies the process of downloading, managing, and running the LLMs on our local machines. So what it will does, packages model weights, the brains of LLM, and a light inference server into a single, easy to use command line application. Ollama itself here is an CLI. You can also use graphical user interface also. So once the model is running, Ollama exposes a REST API at the port number 11434. Remember this, you will be using this in building the application. So where we can interact with the LLM with our programming language. So if you are developing the application in Python, you can interact with your Python code. Your Python code will interact with the Ollama models, Ollama's model. Okay, here I have used the model Llama 3.2. 3B is nothing but 3 billion parameters. Llama was developed by the company called Meta. This is an open weight instruction tuned model from Meta AI. The 3B signifies, as I told you, a parameter is a value within the model that is adjusted during training to capture knowledge. So that nothing but parameter is a value for a particular word or something. So some other models are also there, like 70 billion parameters, which are more capable. So in our system, we have downloaded the 3 billion parameter to run efficiently on consumer hardware. So everyone laptop not able to support to all the models. So with limited RAM, I have used the Llama 3.2. Prompt engineering. You know how effectively you're giving the prompt, that much effective you'll getting the results. So a effective prompt can be consist of role, context, and output formatting. So for example, role assignments, instructing the model to act as a specific persona. I mean, you are in software mentor or tutor. You have developed many applications like that. We are giving a role and contextual information. For example, in our context, it is an e-commerce store. So we are giving the context as in providing the store's return policy within the prompt like that. Output formatting, specifying how the response should be. So we are example respond in a single paragraph under 50 words like that. Prompting techniques like zero shot, one shot. There are many like COT, chain of thought, and React, reasoning and acting. So in zero shot, you just were giving role, context, that's it. And in the one shot example, you will explicitly mention an example about user query and how the model response should be. So that models will try to understand, okay, has been given like that. So I need to respond in such a way within the prompt before asking the actual question. This helps the model better understand the desired tone, format, and style of the response. So coming to the dataset, here we have created an artificial dataset by using another dataset called Ubuntu Dialog Corpus. So this is a publicly available dataset containing over a million multi-ton technical support conversations from Ubuntu's IRC help channels. So based on this Ubuntu's dialog corpus, we have created 20 queries, nearly 20 queries based on the context of this Ubuntu dialog corpus, so that we'll be know the actual human tone and format. So coming to the system architecture and data flow, our Python code, our Python script, chatbot at Py, will be interacting with the Ollama at post number 11434. So the Ollama server running locally. Pass the prompt to model, which is the Llama 3.2, and generate the text response and package with the JSON with generated text, and we will store the response of the each query in a result.md file, markdown file. Okay, let's start exploring this. This is a previous project. Offline chat. Okay, first let me show you the how one shot and zero shot prompt should be like that. So this is the one shot where we will explicitly mention how the model should respond. So we are setting the tone and assigning the role, and saying that keep your response under 60 words. This is the prompt will be going to the Ollama's model. And do not make up a specific policy if you are not sure. Instead, guide the customer to contact support. Do not mention any other brand or store name. This is the instructions we are giving to the model. So, example, what is your return policy? We offer a 30-day return policy for all unknown items. This is an example query, and how the agent response should be. So, actual query will be given in the command prompt, or it will be loaded from our prompts. Zero shot template. So in zero shot template, we are not mentioning any query. I mean, how the model should respond. Just we are setting the tone and assigning a role, and the giving specific context. You are an helpful, friendly, and concise customer support for an online fashion called Chick Boutique. So this is a fictional one. This is not present exactly. So for that, I have created an virtual environment where we can download all the requirements. So first, see data. So I told you I have used an Ubuntu dialog corpus as an example one, and created my own dataset with the 20 plus prompts. So just exploring that. Last wait, it's been running. So meanwhile, I will show you the Ollama. So this is the Ollama interface where we can explore it completely offline. I have used the model Llama 3.2, which is a 3 billion parameters, and some other models like GPT OSS developed by the OpenAI. This is also OpenAI, DeepSeek, and Quandary Coder, which was developed by the Alibaba's company, Llama, which was developed by the Google. So like that, there are different types of models where we can interact. So let's see whether this works offline or not. Let me. What is an error? So saying that this is completely working offline, where I turn off the internet. So see, that's how it works without internet. Okay, the prompts has been used. So yeah, this is a prompt. I mean, queries present in the Ubuntu dialog corpus. If you want to access the dataset, you can go to Hugging Face and search for set Ubuntu underscore dialog question and answer QA. Show you let's it way. So here some queries are there. For example, your resource is to reinitial flash the older version. Hi, there is a CLA command to back to any like that. There are different queries given by the users. You can check out this at Hugging Faces. And for Ollama, you can simply go for Google and search for ollama.com. Let me show you wait that also. Yeah, it has been generated for that purpose. Let's stop this. Yeah, Ollama's website. You can download if you are using Windows, or you can use Apple. You are using macOS. You can use to download for macOS. And later we need to download the model Ollama by running the command Ollama pull your model your wish. Yeah, Ollama run. Or first we need to pull the model and then we need to run the model. So this works completely offline in your command prompt Ollama run 3.2 column 3B 3B. So we have seen the how the dataset looks like. Okay, let's explore this chatbot.py file where we need to import the requests and import OS for making file operations, JSON for extracting the output in JSON format. So I have told you that we need to interact with the Ollama and API, Ollama through an API, which is running at port number 11434. Here you can use localhost, but it's not working. So that's why I have converted into numerical format 127.0.1 and model name Ollama 3.2. So I have told you I have created a 20 prompts based on this context. So for example, how do I cancel a request just order I just placed? Like that I have created 20 prompts. So first I'm loading a template. I mean whether it can be one shot or zero shot template. File path equal to os.path.join prompts comma file name. So I have told you a OS module we use it for making file operations modifying or something like that with a file path R means reading mode as file return file dot read. I mean content of the file. Okay, first we need to query the Ollama query Ollama method where we will be giving a prompt and a payload. It is an JSON consists of key value pair model name. We have created Llama 3.2 at the top and the prompt and stream equal to false stream column false. Okay, first we need to how to say exception handling. Try what we are trying getting a response from the Ollama model. Request that we are sending a a post request where Ollama endpoint and a JSON equal to payload. So here is the payload that we are sending and response is dot for status and data equal to we are storing the 10-year data and in that we are removing the unnecessary spaces using dot strip method and except if any connection error is there, Ola could not connect to Ollama, is Ollama running? We are generating an error which will be understandable by the user. So saying that Ollama is not reachable. So for example, if there is an HTTP or error, we are saying that bad response from Ollama and returning the error. So once the response has been generated, we need to evaluate the responses generated by the model. So for that, I have created a evaluation a folder name, and just it will be created and store the results in the results.markdown file. This is already has been generated. So we are evaluating the model response based on three metrics. One is relevance, another one is coherence, and third one is the helpfulness. Relevance means how well does the response address a query. For example, whether it is generating the response based on this context, or it may be helpful or not, like that. And coherence. Coherence is nothing but we are checking the grammatically correct or and logical. And helpfulness, does the response provide an useful or actionable answers. So based on that purpose we are evaluating the model, and we need to evaluate the model completely manually, and the result will be stored in the results.md. Okay, let's see. Yeah, Ollama has been in running state. Okay, in the another PowerShell we will. Yeah, it will take a little bit time because it's an CPU based laptop, not GPU based. Yes, the Ollama runner started. Okay, it will maybe taking time. Meanwhile, we'll explore the GitHub URL. Yeah, for yeah, you can check out this project at the GitHub URL named Satyanarayana Praveen Kumar slash offline customer support chatbot. So coming to the Redmi, this is about complete project details. So tech stack I have used model Llama 3.2, which is 3 billion parameter, and runtime I have used Ollama, which is completely in local, not on the cloud basis. And language we have used completely Python. And output we have stored in the results.md file, where responses and manual score will be given. Okay, let's see whether the scores. Yeah. Okay. For understanding purpose, I will show you this in an Markdown editor. So this is how the generated response. So we are considering three metrics, mainly relevance, coherence, and helpfulness. So we can score these responses manually by simply typing 1 4 like that. It will be rendered this side. So that's how this will be generated. And how to run, you can check out the setup.md file. So how to check the Python version, Python hyphen version, and install Ollama and verify Ollama hyphen version. So in order to pull the model from the internet, we can use Ollama pull Llama 3.2 column 3b, which is beam is billion parameter, 3 billion parameter. And you want to interact with the model through command line, you can simply type. I'll show you. Llama and Llama. Okay, I have included it. So you can interact with the model through command line also. And in order to exit from the chat, you can simply type slash chat. So let's see, without internet. What is Ollama? Okay, Python program. Print hello world. Let's see whether this can write or not. Yeah, it has been running and saying the instructions to how to save the file and how to run the file. Yes, see, you can see this is completely working offline without internet. In order to exit from the chart, simply type slash by. That's it. And in order to interact with the datasets, that's it for today. We have showed, we have see how Ollama works offline and how we need to interact with the model and how to download and verify the Ollama version. So and how to evaluate the model responses and how to store the responses in results file. So everything we have seen. That's it for today. Thank you.